A phylogenetic tree is a diagram that displays the evolutionary history of a group of organisms. The trees can represent relationships between any related groups, from all life on Earth to specific subspecies of algae. Phylogeny assumes that every organism shares a common ancestor and that all organisms fit in the tree of life. Though phylogenetic trees are often hypotheses, based on indirect evidence, they are nevertheless useful in studies of evolution and ancestry. One important feature of phylogenetic trees is a node, the point where one branch splits into two. Each node represents an ancestor of future organisms that will develop in two separate lineages. If you follow the node to the tips, you can trace the lineage from the common ancestor at the node to its descendants along the branches. At the tips of the phylogenetic tree are the ultimate descendants of the ancestors farther back in the branches. Each branch symbolizes a progression of organisms evolving. For example, the branch leading to a tip labeled mouse would include the chain of organisms evolving to become mice. Phylogenetic trees allow you to see how closely related two organisms are. Relatedness, in phylogeny, has a very simple meaning: the more recent the common ancestor, or node, the more closely related two organisms are. Based on this principle, siblings are more closely related to each other than grandchildren are to their grandparents, because siblings share a more recent common ancestor, their parent. By the same logic, rodents and humans are more closely related than snakes and humans, because the common ancestor of rodents and humans is far more recent. Recent here isn't based on actual calendar years but instead on the amount. When reading a phylogeny, make sure to read from the nodes to the tips. Phylogenies depict lines of descent, not similarity. Even if two branches or tips are next to each other, that doesn't necessarily mean that their organisms are more closely related. Take care to trace from nodes to tips to determine relatedness. The illustration of phylogenetic trees can vary while containing the exact same information. Phylogenetic trees are sometimes drawn with diagonal branches, sometimes rectangular, and occasionally even circular, but the shape is irrelevant. The tree can also face in any direction. In addition, the direction in which each branch points can switch without changing the meaning of the phylogeny. No matter how the tree looks, the key to understanding it is locating the nodes and the tips. One way to classify parts of a phylogenetic tree is to distinguish between monophyletic and paraphyletic groups. A monophyletic group, commonly known as a clade, includes an ancestor and all its descendants. In contrast, a paraphyletic group comprises an ancestor and only some of its descendants, with others left out. There's a simple visual trick to determining whether a group is monophyletic or paraphyletic. If you can cut the group off from the rest of the tree with a single slice, the group is monophyletic. If cutting off the group requires multiple slices, it's paraphyletic. These distinctions are a helpful tool for deciphering and analyzing phylogenetic trees. Drawn this diagram to understand the phylogenetic tree.